Hello and welcome to Lesson 40 of Additional Maths with Mr. Barrow. And today we're going to be looking at integration, which is the reverse process of differentiation, and both are part of calculus. Before we go through this worked example, I want to talk about integration as a whole, okay? And how it fits within the processes of calculus. So, if you have a function y equals f of x, we know from previous lessons that if you differentiate that, you get the function dy by dx, which is the gradient function of the curve. And that's called f dashed x as well. So f dashed x is the other notation, which means differentiate the curve f of x. If you differentiate again, we know that that becomes d squared y by dx squared, which is the rate of change of the curve. In effect, the rate of change of the gradient of the curve, and that would be f dash dashed x. Okay, so that would be the second derivative, and we could keep going ad infinitum. Okay, we could continue that process forever. As we go down through the derivatives, that process is differentiation. Differentiation takes us from one derivative to the next derivative. Okay, takes us from the curve to the gradient function, to the gradient of the gradient function, etc., all the way down. Integration is the process of going the other way. Integration takes us from the gradient function back to the curve, takes us from the second derivative back to the first derivative. So that is the process of integration. And it is just the process that reverses differentiation. And it has some other very useful effects as well, which we will learn in a future lesson, to do with area and things like that. So let's see if we can find out how we can integrate now that we know how to differentiate. So let's talk about what we know so far. For differentiation, we know that if we have y is equal to a times x to the power of n, where a and n are some constants, okay, so they stand for some number. If we have that function, then we know that dy by dx is equal to, what we do is we bring the old power down, so n multiplies by a, and then the power of x, so the n drops by 1, so it becomes n minus 1. So the process of differentiation takes us, it multiplies the expression by the old power, and then after that the power drops by 1. So that is the process, the basic process of differentiation if we have individual powers of x. Okay, so as integration is the reverse of differentiation, all we need to do is reverse this process. So instead of going this way, which is differentiation, we're going to go the other way. And we're going to reverse everything that's happened. So the first thing is we're going to increase the power by 1. So that's the first part. And then after that, we divide by this new power. So that, in essence, is what you do when you integrate. You increase the power by 1 and you divide by the new power, and then you've got your new expression. So what that looks like. I'm now going to show you the integration symbol. So this symbol, an elongated S, tells me to integrate the following expression. So if I have this integral symbol, it tells me to integrate ax to the power of n. And the dx afterwards is very important. It tells me that I want to integrate this expression with respect to the variable x. So treating the x as the variable that I want to increase the power of. Okay, So if I use this process of increasing the power by 1 and then dividing by the new power, think of what you're going to get. So if x has a power of n, so if I increase that power by 1, I get x to the power of n plus 1. And then if I divide by that n plus 1, I get either, I can write a times x to the power of n plus 1 all divided by n plus 1, or I could write the a over n plus 1 in front. So that is what I get when I integrate. But I also get plus some constant afterwards, and I'm going to explain why in a second. So not only do you get a power of x which is 1 higher and we divide by that new power, we also get plus a constant. Okay, so let's see why we get that constant. So let's talk about the constant of integration, this plus c. Imagine I've got these functions. First one, y equals 7x squared plus 3. The second one, y equals 7x squared. The third one, y equals 7x squared minus 10. I'm going to differentiate each of them and give the gradient function for each of them. So 7x squared differentiates to multiply by the old power, so 2 times 7 is 14. And then drop the power by 1, so that becomes x to the power of 1, so 14x. And the 3 differentiates to nothing, because remember that 3 is really 3x to the power of 0. So if I multiply by that old power 0, it becomes 0. So the gradient function of 7x squared plus 3 is 14x. Let's look at the gradient function for 7x squared. Surprisingly enough, it's also 14x. And for 7x squared minus 10, also 14x. It didn't matter what constant I had afterwards, whether it was plus 3, plus nothing, minus 10. All of them, those constants, differentiated to 0. And hence, if I have a gradient function which is 14x, so if all I'm told is that dy by dx is 14x, then I cannot say for sure what the original function is. All I know is that if I integrate 14x to the power of 1, it becomes 14x to the power of 2 divided by 2, so 7x squared, plus something, because the something could be any number which then would differentiate to 0 in my gradient function. So any curve of this form would have a gradient function which was just 14x. The reason for that is because all these curves have the same shape. They are just translated up or down by the constant. So if we start with y equals 7x squared, the y equals 7x squared plus 3 is just the same curve, but just 3 higher. So it would have the same gradient for every x value. It would just have a different y value. And the y equals 7x squared minus 10 would just be 10 below the y equals 7x squared graph, but it would have the same gradient at each point. Okay, so when you integrate, if you don't have any other information, you must make sure you put plus c at the end. Okay, so let's put that into practice now. Let's have a go at this question. So, find the original curve's function given these gradient functions. First one, dy by dx is 15x to the power of 4. So what I want to do is I want to find out what y is equal to, what the original curve's function is. So I want to integrate 15x to the power of 4. So y will equal the integral of 15x to the power of 4 with respect to x. So y is equal to, so if I integrate, I raise the power by 1, so was power of 4, so it becomes a power of 5, and I divide by that new power of 5. So the 15 is then divided by 5. And that gives me the function y equals 3x to the power of 5. And I've forgotten something. I forgot to put plus c. So it's y equals 3x to the power of 5 plus c. So that there is the original curve's function if the gradient function is 15x to the power of 4. Next one. So if I have the gradient function f dash x is 7x cubed minus x squared, remember they could either use dy by dx for the gradient function, or they could state f dash x. Those mean the same thing. So to find f of x, I need to integrate 7x cubed minus x squared. Okay. This, by the way, this step here, you can think of. I'm just writing it down. I'm being very explicit about what I am doing. To find the function, you need to integrate the gradient function with respect to x. So when you're writing it, you're usually just writing f dash x equals 7x cubed minus x squared. Then you write directly underneath that f of x equals, and you integrating each term separately. So the 7x cubed, the power raises by 1 to x to the power of 4. And then I divide by that new power, so I divide by 4. So it becomes 7 quarters x to the power of 4. The minus x squared, the power raises by 1 to 3. And then I divide minus 1 by 3. So it becomes minus 1/3 x cubed plus c. So that is my original curve's function. If the gradient function is 7x cubed minus x squared, the original function is 7 quarters x to the power of 4 minus 1/3 x cubed plus c. And the last one, find the following integrals. Sometimes they won't talk about curves and whether you have a gradient function or the second derivative or anything. They might just say integrate the following thing. So if I want to integrate 8x plus 5, I just integrate 8x first. That currently has a power of 1. So I raise that to a power of 2, and then I divide by 2. So it becomes 4x to the power of 2. When it was 8x to the power of 1, we then divided it by 2, which was the new power, became 4. And the 5, remember that 5 could be thought of as 5x to the power of 0. Okay, so if I'm integrating 5, I'm integrating 5x to the power of 0. So I increase the power by 1. So it becomes x to the power of 1. And then I divide by that new power, so I divide by 1. So the 5 stays as 5 because it is divided by 1. And then I put plus c. So my answer to that is 4x squared plus 5x plus c. So that is the integral of 8x plus 5 with respect to x. Okay, so it's now time for you to have a go. So have a go at these 3 questions. Okay, 1a and b and 2. So find the original curve's function given these gradient functions. First one, dy by dx equals 28x to the power of 6. Second one, f dash x equals 11x to the power of 4 minus x. And then question 2, just find the following integral. Integrate 12x minus 7 with respect to x. Pause, write down some maths, and then press play when you're ready, when you've got an answer. So the answer to these, first one, if dy by dx is 28x to the power of 6, then you integrate that, you get y equals, the x to the power of 6 becomes x to the power of 7. We divide by that 7, so the 28 divided by 7 is 4. So it becomes y equals 4x to the power of 7. And we also have the constant of integration plus c. The next one, if f dash x equals 11x to the power of 4 minus x, then f of x will equal, we raise the power by 1, so that x to the power of 4 becomes x to the power of 5. And then we divide by that 5. So 11 becomes 11/5. So it's 11/5 x to the power of 5. Next, minus x to the power of 1 becomes minus x to the power of 2 divided by 2. So it becomes minus 1/2 x to the power of 2. Because minus 1, the coefficient, you halve it, you become minus 1/2 x squared. Plus c for the constant of integration. And then the last one, integrate 12x minus 7. You raise the power of 12x from 1 to 2, and then divide by 2, it becomes 6x squared. Minus 7 just becomes minus 7x to the power of 1. or just minus 7x, plus c. By the way, whenever you have just a constant, when you integrate it, you just get that constant as a coefficient of x. So if you integrated 37, integral of 37 with respect to x, it would just become 37x. Okay? So if you got those three answers, that's brilliant work. I'm now going to show you another example where we try and find out the value of c if we are given a little bit more information. So before you go away and practice, I'm going to do another example first. So the second worked example. Find the equation of the curve with a gradient function dy by dx equals 6x squared minus 7, which passes through the coordinate minus 113. So before, if I just said the gradient function was 6x squared minus 7, you could give me a general form of various curves which would have that gradient function, because they would all have it would have a plus c at the end, so there would be an infinite number of possible options. But now I have created a unique answer because I've told you a point which this curve goes through. So then that isolates what the c could possibly be. So the way to answer this first is to find the general form of the curve. So the y equals in terms of x and with a plus c at the end. And then use the information from the coordinate to find the value of that c. Okay, so let's do that. So if dy by dx is 6x squared minus 7, then y will equal the integral of that. The integral of 6x squared is 6x cubed divided by 3. So we raise the power by 1 to 3, and we divide by 3, so that becomes 2x cubed. Okay, because 6x cubed divided by 3 will be 2x cubed. The minus 7, as I talked to you, when we have just a constant, you just get minus 7 with an x on it. Okay, becomes x to the power of 1 when it was x to the power of 0. And then we have a plus c at the end. So that's the general form of the equation of the curve. Now, to find the value of c, all I need to do now is substitute in this coordinate. So when x is minus 1, y is 13. So 13 will equal 2 lots of minus 1 cubed minus 7 lots of minus 1 plus c. And then if I work through that, 13 will equal, well, minus 1 cubed is minus 1, times 2 is minus 2. Minus 7 times minus 1 is plus 7, plus c. So then c is equal to, so 13 will equal 5 plus c, so c will equal 8. And now I've got my equation. So I know the specific equation I want is y is equal to 2x cubed minus 7x plus 8. That is the unique equation with that information. So the steps you went through, first you integrated, then you substituted in the coordinate to find the value of c, and then you restate the equation with the value of c found. Okay, have a go at this one, which is very similar. Okay, I give you the gradient function of a curve and a point it passes through. I want you to find the equation of the curve with that information. So find the equation of the curve with the gradient function dy by dx equals 8x minus 5, which passes through the coordinate minus 2, 33. Pause, write down some mathematics, and then press play when you're ready. So the answer is, firstly, you integrate. 8x integrates to 4x squared, minus 5 integrates to minus 5x, and you have plus c. Then you substitute in the coordinate. So 33 is equal to 4 lots of minus 2 squared, minus 5 lots of minus 2, plus c. If you evaluate c, you get c is 7. So then your answer is y is equal to 4x squared minus 5x plus 7. If you got that right, that's superb. Now it's time to practice and make that process fluent. Fluent means fast and without too much thought needed. Okay? It's just a fluent process. It's part of your skill set. It's not something you need to think long and hard about. So exercise 15.1 from the textbook is a good place to start. Remember that if you have an expression, so if you're doing that exercise, in question 1, there are various ones which might catch you out. So the first one which might catch you out is the fourth part. So dy by dx is equal to x minus 2, 3x plus 2. You cannot integrate in that form. You must make sure you expand the brackets first before and write it all out as separate expressions before you then integrate each individual one. Okay? All right. Off you go and enjoy. And I will see you in the next lesson where we take integration to the next level. Goodbye.